In this video, we'll explore solving quadratic equations. Now, some general suggestions. First, it helps to rewrite your equations so that they're ax squared plus bx plus c equals 0. If you don't have that bx term, then it becomes much easier to solve because it's just typically a two-step equation where you take the square root in the end, and you're going to end up with a plus or minus the square root of typically negative c over a. If you do have that bx term, then you're going to factor by grouping. And if grouping doesn't work, then you can try completing the square or the quadratic formula. Now, we are only going to be solving for real solutions, so if you get a negative inside your square root, which would typically give you a complex value, we're going to say that the solution is no real solutions. So let's look at this example. 4x squared minus 32 equals 0. We're missing that bx term, so we can just solve for x. First, we add 32 to both sides. Then we're going to divide by 4, and then we're going to take the square root. And when we do that, we want to simplify our square roots, so this would simplify to plus or minus 2 the square root of 2. And remember, it's always plus or minus when we take the square root. Now we can check our solutions just like we could with any other type of equations. So if we plug in a positive 2 square root of 2, we simplify that, we would end up with 32 minus 32 equals 0, so 0 equals 0. That is exactly what we want to happen, so that solution is correct. Then we can plug in negative 2 to the square root of 2. We simplify, and we still end up with 32 minus 32, so 0 equals 0. So both solutions are solutions for this problem. Now say we have this problem, x squared minus equals 7x plus 18. In this case, we need to rewrite our equation so that it's ax squared plus bx plus c equals 0. So, first thing we need to do is move the 7x and the 18. So we have to subtract them from both sides. Now we have that x squared minus 7x minus 18 equals 0. And now we need to see if we can factor that. So we're going to look and say, what's the product of 18, negative 18, and the sum of negative 7? And we can go through several, and here are two that I tried and got it on the second one. If I do negative 9 times 2, that gives me negative 18. And if I do negative 9 plus 2, that gives me negative 7. So now I can go through and group factor. I replace my middle term with my two factors. I group, and then I pull out whatever I can. And I see that I have my identical parentheses. So I know that my exterior will make one set, and my identical one makes the second set, x plus 2 and x minus 9. So now to find my solutions, I set each of those factors equal to 0 and solve for x. So x plus 2 equals 0, x minus 9 equals 0. So x is negative 2 and positive 9. Now I do want to check my solutions again. So I plug in negative 2 in the one, and I'm going to plug 9 in the other one. Negative 2 squared is 4, negative 14. So 4 equals negative 14 plus 8. That's going to give me 4 equals 4. And if I look at 9 squared is 81. 7 times 9 is 63. 63 plus 18, 81. So both of them make true statements, so both are solutions for this quadratic equation. Now, sometimes I have harder problems that I can't just do a basic factor, and then I'm going to either complete the square or use the quadratic formula. So if I need to complete the square, I'm first going to rewrite my equation so that I move the c value to the other side, and I'm going to leave a blank there. If I have to, I'm going to divide everything by the a term so that this is 1x squared. That's important. It has to be 1x squared for this to work, because the idea of what I want to do is turn this term into a perfect square. So what I do is I'm going to take my middle term, my b term, I divide it by 2 and then square it. So b over 2 quantity squared. If I add that to both sides, I now am going to have a perfect square on the left hand side that I can then take the square root of each side and simplify to get my solution. Let's look at an example. So if I did x squared plus 6x equals 10, If I move the minus 10 over, I'm not going to be able to factor that because there's no factors that are product of negative 10 and add to be positive 6. So I go the other route. I say, okay, well, let me try to complete the square of this left-hand side. I'm going to divide 6 by 2 and then square that. That gives me 9. So if I add 9 to both sides, remember, I've got to do it to both sides because I have to be always keeping things equal on the two sides. If I remember how to factor this, this becomes x plus 3 quantity squared, and then 10 plus 9 is 19. To remove that square, I take the square root. And remember, a square root you always get plus or minus. So I have x plus 3 equals the plus or minus square root of 19. To get x by itself, I'm going to subtract 3. So negative 3 plus or minus the square root of 19 is the solution. It's not a nice looking solution, but it is two real solutions here. Now I could also have used the quadratic formula. Quadratic formula, I keep it in that ax squared plus bx plus c situation. And what I'm going to do is I'm going to plug in the a, the b, and the c into this formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I have to pay attention. If this inside part, called the discriminant, b squared minus 4ac is negative, then there are no real solutions because this would become a complex number. So let's go back and look at that problem we just worked. We know that it was not factorable in the ways that we would do a basic factor. We could complete the square, or let's try the quadratic formula. First I need to rewrite it so that all the terms are on the same side. And I can say that my a value is 1, my b value is 6, my c value negative 10. Important to remember that negative there. Now I'll just plug in a, b, and c. So negative b, so negative 6, plus or minus, so I did plus over here, minus over here, 6 squared minus 4 times 1 times negative 10 over 2 times 1. And here, same thing, just change that to the minus, because I got to do plus and minus. Now I'm going to simplify inside. That becomes 36 plus 40, which is 76. Now the square root of 76, I want to simplify that radical, and what I end up with is 2 the square root of 19. Now if you remember how to simplify your fractions, I can divide all three terms by 2 and end up with negative 3 plus square root of 19, negative 3 minus the square root of 19, which is exactly what I found by completing the square.